Okay, so from last week, what does it mean to be or become chemically stable? What's actually happening? And it's one of them things you may have to think about. It's probably easier to illustrate what we mean by becoming chemically stable as opposed to just blurting out an answer. Okay? It has something to do with the Bohr model that might help you explain that. And what might that be? Has to deal with the electrons. Yeah, that's true. What's that? Okay, so what does it mean to talk about valence electrons? You're right. That has something to do with it. Because what is it that these elements want to do with their outer shell? To complete it, to either add or subtract. So something on the right-hand side of the table, with the exception of the noble gases. Who's right next to the noble gases? It's column 7, halogens. So how many valence electrons is that? It's 7. Okay. So what's the goal of any halogen? To lose 7 or gain 1? Yeah, gain 1. Then it's got 8. It has a complete outer shell then, and we call that chemically stable. So what's just the opposite of gaining? Well, losing an electron. Who would possibly lose electrons? Metals. Metals is a good answer. Alkali metals, alkaline earth metals, transition metals, any one of those. So what does it mean? Why does magnesium have a positive 2 charge then? Why is that? You could say, well, it's in the second column. Yes. Okay. Staple these. Don't staple them. I don't think anyone has. If you want to staple them, fine. If not, then just keep passing the stapler. Okay, I got one more. Is this everybody then? Okay. So, as a quick review, okay, when we look at magnesium, okay, what's inside the nucleus? What number? And so those over on the far left can answer that. Look, find magnesium. Okay, so why is that 12 significant? It's the atomic number. Gives you a number of protons. So, if this is neutral, how many electrons is that? Okay, so following your slide rule, look how easy this is compared to the first time. Remember seeing this, thinking, this is awful, but now it's old news, right? We hope. Yeah? All right. So there we got 12. Okay? So you had correctly said metals, like magnesium, want to do with, what do they do with those 2 valence electrons? Yeah, get rid of them. So once that has happened, this number does not change. Once these are gone, positive 12, negative 10, add them together, you get plus 2. So what does it say inside element 12's box in the upper right-hand corner? Plus 2. Does anyone not understand how those charges get there? Okay? If it's losing electrons, okay, it's gaining in charge. If it's gaining electrons, it's losing its charge, or lowering, if that makes sense. What I mean by that, if it loses these 2 electrons, maybe one went to one chlorine atom and another one went to another chlorine atom. When it loses electrons, it forms a positive 2 charge. Then when it gains those electrons, it becomes a negative charge. Okay? And that's why you see just a negative dash inside the halogens box. Okay? Whether it's fluorine, chlorine, bromine, or iodine. Okay? And then that's why it says +2 in magnesium's box. Again, because it gave 2 electrons away. Now, what may happen throughout the course of the day, I will probably hand out, okay, tomorrow's paper yet today. I don't have it ready this hour yet, okay, or I guess it's not Wednesday's paper today. It's going to be one of those aspects to where if we don't have school, which is quite possible, I don't know, depends whether you believe the weatherman and depends how the forecast is perceived, what the weather actually does, okay? Is anyone looking at this week and saying, let's not have school this week? Is that anybody? Okay? Okay, so what happens, now this is the other end of that extreme. May 16th rolls around, we're still sitting here. May 17th, we're still sitting here. May 18th, that might be a Friday. Then May 22nd, we're coming back. Okay. Now, obviously, we can't control the weather. And with that being said, I know it's just human nature for those of you who did put your hands up saying, God, I hope we don't have school tomorrow or the next day. Yes, I know, I get it, but believe it or not, we are looking for your best interest. You might not believe it, but we do want you to succeed, believe it or not. Whether you believe that or not, that's entirely up to you. So should that happen, or should we have another late start, okay, let's say, for instance, the weather is bad on Wednesday, we decide to have a 2-hour late start, chances are when 10:30 rolls around, okay, we probably would not have class. We'll start with first hour, okay? That means we'd be missing class. So we'll try to put together some of those little short videos on the Science Channel that'll help point you into the right direction. So it's probably going to be in your best interest that we do have school. Okay, we're in February now, and obviously the days are getting longer. So hopefully everyone's in a more positive or better mood. And the reason that is the days are getting longer. When it's cold, dark days, there's a couple of reasons. I was having a conversation with a student with orange juice, Sunny D. Okay, it really gets its name for 2 reasons. One, it's short for delight, isn't it? Sunny Delight, Sunny D. And then probably the more logical reason, why do you suppose it says D? Vitamin D, okay? And that's obviously going to be a good source for that. Okay. So atomic stability then comes to when the outer energy level of the atom is full. Now, whether that has gained or lost electrons, that's the goal of these elements, to become more stable. Okay? And I do believe that is one of your vocab terms as well. Let's shoot for Friday, having them done. Okay? So your vocab, I'll write that down a little later. Okay? That vocab will be due on Friday. So you have plenty of time to work on that. And I'm not going to ask for these students to say who they were, but some of your classmates poked their heads in this because I told them to. There were some juniors in here. They're in general chemistry right now, and what we're going over now, especially when it comes to writing these formulas out, if we don't catch it that first time, okay, well, we'll try to catch it the second time before you take general chemistry, because what is we're going over now is going to be vital for your understanding when you do take general chemistry. But that's 2 years away. Does that mean, we'll just forget it? I would suggest that we try not to do that, but I can't. I think I remember who it is, but I'm not going to point at them. But that they were not having fun, and not that taking a problem quiz is fun. Okay, it's probably maybe about like having to shoot free throws when the game's tied or you're down by one. Okay, especially late in the game. That's where you say, give me the ball. I want the ball. Okay. Regardless, we move forward. Okay. So, again, unique noble gases. Even if we didn't see this, what makes them unique? Yes, when you look at column 8, they are chemically stable because their outer energy level then is full. Because for the most part, when we're talking about reactivity, for those of you sitting on that far side, you can't see that. Probably just from this row here, okay? Radon, 0. Xenon, for the most part, is 0, but it does take a lot of energy to get those krypton and xenon elements to react. Otherwise, helium, neon, argon, and radon are too unreactive because they're already stable. They're in column 8. They don't want to react with anybody. Now, that doesn't change some of their physical or chemical properties, because some of you who have I don't know what it takes for a plasma cutter. I've never used one, but have used a wire welder. Okay? So I think you call that, is that TIG welding? Did you say mm-hmm? Oh. Does anyone know what TIG stands for? Tungsten, and the I is inert, and the G is one of these. But which one? Tungsten inert gas, I believe, is TIG welding. Take a guess. That was a good guess, because that's right. Okay? Because if you were to go down to the shop, I would be led to believe it's probably, most of the welders are they Lincolns? Does that sound right? And that's maybe something that you maybe looked at, Lincoln or Miller. Those are two probably the most well-known brands of welders. Because when you look at that, you have your stick welding. Bzzz, you're shooting some electricity through there. Then your TIG welding, which actually uses argon. So if you're sitting there and you're saying, well, we just said that they are very unreactive. How is that used in welding then? Well, since it is a gas, what do you suppose is a chemical property of most gases? Say that again. Yeah, they are extremely flammable, okay? Not all gases, because one of the things to think about from earth science. Is anyone rolling their eyes, or we miss earth science? You miss earth science. Okay. You want to be a geologist, don't you? Volcanologist. Do you know why you should be a volcanologist? Where do you suppose a lot of your research takes place? Hawaii. Be a volcanologist. Yeah. Go visit Jessica. Yes. Anyway, when we're talking about earth science, one of the things that's going to happen, and this was throwing these, I don't know why I'm looking at you, these chemistry students, was giving them fits. One of the things you're going to have to look at, if you turn it over to page 4, I'm willing to bet diatomic is one of those terms that you see on there. Okay, a diatomic molecule, if you catch this the first time and you understand it, you're going to make your life so much easier. Okay, so diatomic refers to the number 2. What that means is elements like these halogens, this gas, and this gas are diatomic, which means they do not exist in nature by themselves. It has to be H2, N2, O2, F2, Cl2, Br2, I2. Diatomic means you put a little 2 by it because, again, it does not exist in nature on its own. So, what does that have to do with earth science? Well, what's the major component or gas in our Earth's atmosphere? It's not oxygen. Someone said it over here. Not carbon. I thought you said it. Now we're just babbling. See, I'm standing underneath this. My hearing gets worse. Why are you whispering? Say that again. It's not hydrogen. That's in the universe. Nitrogen. Did you say that the first time? No. He said hydrogen. Okay. So, when we look, if you were to analyze our Earth's atmosphere, okay, probably over 3/4 of it is nitrogen. Well, if that's the case, we're not breathing nitrogen, we're breathing oxygen. And one way to answer that, to why we don't breathe nitrogen, is over there on Bob. Which gas is heavier, nitrogen or oxygen? Oxygen is heavier, nitrogen is lighter, so therefore it's higher up in the atmosphere. We do not breathe in nitrogen. And the reason we're spending some time on these gases is some of the physical characteristics, some of the chemical properties. Okay, one that it makes for a funny commercial, but it's really not good for a person where it's a Geico commercial. I want to say it's about insurance, and a helium truck is flipped over and they're calling their agent and saying something about fender bender and what's true about their voices. It's really high pitched. We're not designed to breathe in or run on helium. Okay. Some of the properties of gases. Okay. Helium is such a light gas that as sound moves through a medium called helium, that's what changes the pitch of your voice. Okay. So that's why you hear that high-pitched voice. And it would probably be pretty dangerous for us to really stand and breathe in that much helium. Like I said, it makes for a good commercial, but should a person, I'm going to keep breathing in an entire balloon, that would not be good for you. Okay? So it looks like some of us are looking around and said, I know someone who's tried or done that already. Maybe yes, maybe no. Okay. Now, would that have an effect on the body? I would tend to think so. Again, it's just not that good for us to breathe in that much of a gas. Okay. Because some of the properties, is it possible for some of you to donate blood should your parents sign a waiver form? Can you donate blood? You're nodding your head yes. Oh, that's the stipulation? Okay. So with that, does anyone want to take a guess on what it is they actually test your blood for before? It's not oxygen values. They test your blood for this before you can donate. Yeah, it's the actual iron levels in your blood. Okay, because you're on a roll here, right? So iron has a +2 charge to it. Okay, the reason that we have iron in our blood is the oxygen needs something to bind to. So that's why we have iron in our blood. The problem that can arise is, let's see here, how can I state this? Unfortunately, this may happen in certain homes. The exhaust fan for maybe someone's furnace, whether that could become cracked, or maybe the ventilation just doesn't work quite right. Does anyone want to take a guess on what can happen when that exhaust is cracked or not working correctly that's hooked up to your furnace? It's a gas that gets released. Normally it's carbon dioxide. Anytime you're burning lumber or wood or anything like that, carbon dioxide is being spewed into the air. Not that that's good or bad, but when it loses one oxygen, it's not carbon dioxide anymore, it's carbon monoxide. Okay? The problem with that is the chemical property for carbon monoxide is that it binds or bonds to iron way easier than what oxygen does. So what slowly happens, okay, is what we call carbon monoxide poisoning. People don't even realize that it's happening to them. Because, does anyone know anyone who's ever been anemic? Anemia means you're not having enough oxygen flow through your blood. Could be because your iron levels are too low. Again, that's why they test it before you're allowed to give blood. Because if you're anemic, you certainly don't want to pass that on to the next person if your iron levels are too low. It's not that you're going to affect them, I wouldn't believe, but there's just not enough iron because they're going to need blood for a reason, so giving them low levels of iron probably isn't going to be very good for them. Okay? But again, that carbon monoxide bonds to it too easy or easier than oxygen, so your levels inside your blood continues to go down, and what that would very much mimic is someone going around your neck, and once your neck is in here, they keep squeezing. Okay? Does anyone know how blood gets from your heart up into your brain? Yeah, it's blood vessels, I get that. I'd be surprised if someone knew what it was. It's not the jugular vein, because that's going down. It's actually an artery that's going up. And it's no offense that no one knows that. It's called your carotid arteries. Okay? So when someone calls that the sleeper hold, they're pinching those two arteries off, and you're not getting enough blood up into your brain, and eventually that person, it doesn't kill them, but what is it they do? What? Yeah, they pass out because they're not getting enough blood up into their brain. Well, the same thing happens with carbon monoxide poisoning, except for you don't have that stranglehold on you. You pass out, and eventually there's just no oxygen floating around in this person's blood anymore because it's got carbon monoxide in it instead. So all the body functions that need oxygen shut down, stop entirely. Okay? It's very unfortunate that things like that happen. So, but that's why when you look out in the hallways, for instance, we got or smoke detectors. Not only that, but there's two other detectors that you may have in your house besides smoke. Carbon monoxide and one of the noble gases here that seeps up through the ground. Radon. Radon gas detectors as well. Okay. So, as we move forward then, when these electrons are gained or lost, we form an ion. So magnesium is now +2. That is an ion now. Okay? Or oxygen gaining 2 electrons. It's a -2 charge. That's also an ion. For those of you who weren't here, you're lucky you were absent on Friday, because it depends if Faith is your friend or not. If she's not your friend, I would watch out. Okay? Yeah. Okay. We're talking about potassium chloride. How do you know all this stuff? Okay. All right. So how does it do it then? Do you know? Well, yeah. It has an effect on a specific organ. Nope. Remember, how does blood get up to your brain? Through your arteries. So something is pushing that to the arteries. Your heart. It stops the heart. Okay. Okay. So types of bonds, okay? One of these, the most common and easiest bond to deal with is called ionic bonds. That occurs when these electrons are given away. They're completely transferred. Okay? So what charges are these forming then? Because it's saying it's completely transferring or losing an electron. So if it's losing an electron, what does it have more of? Electrons or protons? It has more protons. Therefore, it forms a positive charge. So those elements, the lithium, the potassium, the sodium and hydrogen, form a positive charge. But what type of positive charge? When we say what type, we mean how many. Yeah, comes from right there. The single electron is completely transferred. Okay? So, if we take this one step further and say the alkaline earth metals, okay, what are we talking about? What column? the second one, because alkali metals is 1, alkaline earth is 2. Then what can we say about the transition metals? Someone over there in the far left, give me an example of a transition metal. Iron would be a good one. How about a different one? Gold, cobalt. Okay. I want something other than iron. Gold works too, but cobalt. That was a really good one to say. What's true about either that iron or cobalt? When you look in those element boxes, what do you see? Besides 26, 27, the atomic mass, it's in the upper right-hand corners. So, what that means is cobalt will either form a +2 or a +3, depending upon what it's bonding with. All right? So we can't, the only 3 columns we can say for certain at this level without looking at the periodic table or having the charges. We know that because these are in column 1, that's a +1 charge. We know that. If it's in column 2, we know that's a +2 charge. We also know the halogens being in column 7, we can safely say that those are a -1 charge. Okay? So we're going to briefly look at some ionic bonds here. Yeah. Okay? When you're done writing this, some of the examples that we went over on the board last week, okay, we'll be done using this overhead, but we won't be done writing things down. So it may be a good time to put them in the same spot. I'm not going to walk around and say, you need to write this down. I would suggest that some of you are not getting the type of grade that you're hoping. Again, to me, I'm a believer in working on these, continually practicing these. We hopefully get better. And if that doesn't happen, please get in and talk to me. I know you probably get tired of hearing that, but unless we address that issue, how can we improve upon it? So therefore, that's where being in high school is your responsibility to make that. Okay, have this information that wants it. Okay. Anyone else fall on the ice this weekend? High ankle sprain while I'm walking the dog, and it's just one of the things that just happens so quick. Oh. Don't worry, the dog's okay. All right. So what we would like to look at here. Okay. One of the things I would suggest, okay, on page 4, okay, on page 4, it is your responsibility is your responsibility to know what this is and means, what this is and means, this, and I would think that these are all on there as well. Does that look correct? Is there like 6 of them on there? Is it page 3? Okay, sorry, yes, the vocab is page 3. Or, excuse me, page 4. So page 3. My mistake. Do those formulas look correct? OH, NO3. Yes? Okay. The reason that that's important and something for you to work on is this is -1. This is -1. SO4 is sulfate. That's a charge of negative what? Carbonate. And negative what? Okay. Is ammonium on there too? NH4? No? Okay. So, one of the things that we see is that these are called polyatomic ions, unlike this chlorine. Okay? This chlorine is a monoatomic ion. And we know, since it's a halogen, it's in column 7, we said we can safely say that we know it has a charge of negative what? Because it wants to gain 1 more electron. So, when you look on your table, chlorine's in the 7th column, so therefore it gets 7 X's then. So it wants 1 more, so what could be an example where chlorine could get that next or single electron that it wants? There's a whole bunch you could pick from. Potassium, lithium, sodium, you're all giving examples of column 1, and that's fine. How about you try to pick something that's not in column 1 or column 2? So to make sense of this, other than hydrogen, lithium, potassium, sodium, you're correct when you say all of them, because they all have a what charge? +1. So what that means is you'd want to be looking on that table, other than column 1, that also has a positive what charge? So what could possibly be an example that has a +1 charge that's not in column 1? Gold can. Look right up above gold. Silver, yep. Copper, mercury, any one of those. They all form a +1 charge. They can. Doesn't necessarily mean they will. Probably the safest one would be is to write silver up here. Okay? Because it says that inside your element box, either looking on that one or yours, when you find element 47, what does it say inside that box? +1. So that means it had 1 that gave it away. 1 what? 1 electron, and it ended up over here. Okay? So when this gained that electron, this became a -1. When this gave 1 electron away, it became a +1. Okay? That is an ionic bond. It's because it's a complete transfer of giving that electron away. Okay? That usually occurs between metals and non-metals. You might say, well, what about hydrogen? Well, remember, hydrogen is in column 1 because it has metallic characteristics. It has 1 valence electron. Yes, I understand it's a gas, but it just gives that 1 valence electron away. Okay? So, what can happen then is a polyatomic ion can also form, okay, ionic bonds as well. Okay? When that cold weather made itself present last week, I think we had talked about this. How many of you maybe have a vehicle you drive to school that's parked outside? When you went out there that Thursday morning, put the key in the ignition, and it's just saying, Don't start me, don't start me, don't start me. Or I said that wrong. Don't start me, don't start me, don't start me, don't start me. Okay, I'll start. Okay. What's true about your car battery? It occurs by a chemical reaction of a specific acid. Does anybody know? Nope. It's actually called sulfuric acid. It's in between a whole bunch of those plates. If you could break open a battery, it's got sulfuric acid that's in between some of these metallic plates. And when you shoot a current through there, okay, or you turn the ignition, okay, what that means is it's causing a chemical reaction to turn your car over. But when it's really, really cold like that, it really does not want to start. Okay? So what that means is we're talking about this guy right here, this sulfuric acid. If we want this to add up to 0, which we do, and hydrogen is a +1, okay? What we did last week was said we need to find the least common multiple between 1 and 2. So what might that be between 1 and 2? It's actually 2. Okay? You might be thinking, well, it's 1. That's the least common factor, but it's not the least common multiple. Because if we did that, okay, and we said the answer that you get when you divide these tells you what to put below. This is fine because 1 divided by 1, yeah, that'll give you 1. But 1 divided by 2 doesn't give you a whole number. It gives you a fraction instead. So when we change that to a 2, okay, what's 2? Now this is just telling you the charge. It has nothing to do with the value. Okay? So it'd be nothing different than saying this is a +2 as well. It's just telling you it's got a charge. So 2 divided by 2 would give you what? 1. 2 divided by 1 would give you 2. So that means what we get when we divide, we put below. So this would be sulfuric acid's formula, H2SO4. Okay? Now, this is getting a little ahead of ourselves, but what happens, the reason we call that an ionic bond is because when we do that, what column is sulfur in? So that means it has how many valence electrons? Okay? So what we would do is put 1 there, 1 there, 1 there, 1 there. There's our 6. Okay? Now, so we've done our sulfur. Now this is a pretty difficult one to do. That's why we're working on it together. And if you understand this when we're done, you're well on your way to being successful with this chapter. Okay? But who's lost right now? Because we really haven't done anything too difficult yet other than just telling you what column this is in. Put 6 dots down because it has 6 valence electrons. Okay? So now we're going to take care of these oxygens. Okay? We're going to put 1 here, and 1 here, 1 here, and 1 here. Now, oxygen is also in what column? Okay? So we would put these down. What's called a coordinate covalent bond. Okay, and then we'll do it for this oxygen. Okay, notice how many letters are around this chlorine? How many X's were there? 7. And 1 E makes 8. So all of these want to have 8 around them except for hydrogen. I think we better stop there. We'll pick up with this tomorrow. Okay, if you have any questions, please make it a point. Say, I need help. All right, pick up with this tomorrow. We hope.